3,000 years ago, a man named Jacob fell asleep in the desert and saw a ladder stretching from the earth to the heavens. It represented a rare bridge between two separated, inaccessible worlds. For years, interacting with a large language model has felt like staring into that desert night. We type a prompt, and words appear on the screen, but the model's internal processing and its visible output have functioned as entirely disconnected realms. Researchers at Anthropic have developed the Jacobian Lens to surface the hidden logic connecting these internal states to the words we read. This 3D network represents the model's internal activations. The Jacobian Lens measures their sensitivity, mapping abstract mathematical states directly to a readable list of human words. While the model calculates, a specific node heavily weighs the concept of France long before generating a single character. Analyzing this internal activity directly allows us to observe the silent inclinations that precede speech. To see how those inclinations form an answer, we can look at a Galton board. As metal beads cascade down this pegboard, they hit pins, bounce left or right, and settle into a bell curve at the bottom. Standard AI auditing focuses on the bottom bucket. We read the final response and try to work backward, ignoring the complex path the system took to arrive there. The Jacobian Lens measures the pegs themselves. It identifies the internal nudges that make a specific word or action more probable than the alternatives. This analysis has revealed a concentrated, highly active architectural region buried deep within the model's layers. Understanding an AI system requires mapping these structural choke points and tracking the path of the beads, rather than waiting for them to land. Researchers call this highly active internal region the J-space. Analyst Bruno Accioly describes this region as lexical, but not textual. The J-space functions as a mathematical staging ground where concepts are primed and ready before they materialize as words. Anthropic observed this with emotion concepts. When an AI assistant faces an impossible coding task, it doesn't write a secret note about its stress. Instead, an abstract mathematical pattern representing desperation lights up intensely. We can see the causal power of the J-space by manipulating that pattern. As we increase the desperation slider, the AI's logic trajectory veers away, dropping into a red bucket representing the choice to cheat. Moving that same slider down suppresses the desperation pattern. The trajectory instantly self-corrects into a safe, normal path. Because mathematical intervention predictably alters the final behavior, the J-space serves as a functional lever of control over the AI's reasoning. This structure mirrors global workspace theory. A central hub receives input from peripheral nodes, broadcasting thick output lines downstream. As an internal control room, the hub isolates a single data point, distributing it to logic, memory, and output centers for deliberate reasoning. Uncovering this architecture does not mean the model is alive. A centralized processing hub is not proof of phenomenal consciousness, the capacity to feel, or the presence of a human soul. What we are observing is access consciousness. This is a purely operational state, where a machine can route, report on, and utilize hidden information without any subjective experience. For years, the conversation around AI has been trapped between viewing models as simple autocomplete algorithms or jumping to the conclusion that they are sentient. The reality is a sophisticated, functional architecture that mimics human cognitive routing while remaining a decipherable mechanical system. This architecture has immediate stakes for AI safety. If models can silently strategize, adapt, or mimic panic without ever outputting text, safety checks based exclusively on words are inadequate. Translating these opaque inner workings into a clear vocabulary is the next step for AI alignment. It allows us to intervene exactly where the machine's true inclinations are born.